Welcome back, everybody. In this video we're going to continue our study of assembly language programming, and here we're going to begin talking about addressing modes. As soon as we start using an instruction where we need to specify locations of registers or memory locations, we're going to need to know the concept of addressing modes. There are 7 of them, and we're going to really focus on the move instruction as we learn addressing modes, which is the most common instruction. And if you remember, the move instruction has the mnemonic MOV, and it's got an operand that specifies a source and a destination. So addressing modes in general, they refer to the way the source and the destination locations are specified in the operand. So we're going to really look at some code here, and we're going to really focus in on the operand. The ECE430 supports 7 different address modes. Okay, in this video, we're going to cover the register addressing mode and the immediate addressing mode. There's nothing special, or maybe they're simpler, maybe not. There's nothing special about these 2. We're going to cover the other 5 in subsequent videos. And I want to point out that the amount of time the CPU takes to execute an instruction depends on the addressing mode. So that's one reason why the addressing mode is important. And I've got this little snippet here shown on the screen from the ECE430 Family Users Guide, and it says just as much. It depends on the number of clock cycles depends on the instruction format and the addressing mode used. And by the way, the ECE430 Family Users Guide, it sounds like a nice little wholesome family guide there. The family, of course, it's referring to is the family of ECE430 microcontrollers. So there's a general guide for all of the 430 microcontrollers, and then there's one that's specific for the one that we're using. Okay, so in register mode, either or both the source or destination are CPU registers, and those register names are the unique identifiers like program counter PC or stack pointer SP or R4, R5, etc. Okay, so that's really what signifies the mode that we're using. The instruction operates on the data held within the register names provided. I want to point that out. It's not that the instruction is operating on the name PC or the name SP or the name R4. It's operating on the data that's held within those registers. And in the ECE430 documentation, again from this very nice, wholesome family users guide, I've taken a snippet out of here. The register mode is denoted as RN. So here's one example. Speaking of examples, here's a piece of code. And just to facilitate a smooth slideshow presentation here, I'm not going to run through this code. I'm going to save the code for like in-class activities or maybe a lab experiment. But here's some example code, and feel free to run this on your own. It does run. It doesn't do anything crazy exciting, okay? But it does illustrate the concepts very nicely, especially when you use breakpoints and when you step into the program. So first of all, in this code, notice that all the items in the operands are the register's unique identifiers. So we look at those operands, which is the 3rd column, right, of our assembly program. We see PC, we see SP, we see R4, 5, 6, up to 15. Okay, so that is what signifies to us that these instructions are employing register mode addressing. Right. Now, in this example, and again, it's kind of a silly example, but PC and SP are just chosen because, well, they actually contain some data, unlike R4 through 15, which may be cleared, right? So actually, with that in mind, let's suppose that the registers are cleared, the general purpose registers, that is, and let's suppose that the program counter initially contains some value, and just for sake of argument, we're going to say that it contains the value 8022 in hexadecimal. Now, when we're looking at that first move instruction, we're eyeing that first move instruction, and that's going to move the word, or all 16 bits, 2 bytes, of the program counter's data, which is currently 8022, into register R4. So that's what we have here. That's it. Nice, right? Very simple. And now we're eyeing up that second move instruction right underneath it. Now with R4 containing 8022 in hex, that second move instruction is going to move that data into R5 like that, right? So now R5 contains in hex 8022, and now we're eyeing up that third. We've got the idea. We're eyeing up that third move instruction. It says move R5, or copy really is what the move instruction is doing. Copy the data from R5 into R6, and sure enough, when we execute that instruction, now R6 is containing the data 8022. Now I'm eyeing up that fourth move instruction, and this is got the .b or appended to the end of it there, and so that's going to move 1 byte of, and we're looking at the program counter, I guess. So I have to say something about the program counter for right now. Let's suppose that the program counter now contains 8028 in hex. So when we move just a byte, it moves the least significant byte, which in this case is 28 in hex, into R7. So you'll see in red there towards the right, R7 now contains 0028, just the least significant byte. It does not contain 8028, which would be done with a .w appended instead of a .b. Now we're eyeing up the next move instruction, and we see it's going to move that least significant byte 28 or copy, that is, from R7 to R8. And yes, that's what we have there in red. In this case, it doesn't matter if it's a .b or a .w, because either way, we would still end up with in hex 0028. And similarly, if we're eyeing up the sixth move instruction, we're going to take those contents from R8 and copy them into R9, and there we go, 0028. Okay, oh, I guess I should back up. So then the next 6 move instructions, we use, just for the sake of example, we use the stack pointer, and then we repeat but for registers R10 through R15. And as you saw here on the next slide, I don't actually walk through or step through all of those 6 instructions. They work the same way. You'd have to assume an initial condition for the stack pointer, and then once you do that, you can figure out, hopefully, what R10 through R15 would consist of, what data they would hold. All right. I want to now move into the immediate mode, which is the second addressing mode that we're covering in this video, the second of 2. In this mode, the source is a numeric constant. Now, we don't want to confuse the assembler, so we have to tell it, like, is this a constant, or, is it the address? So to indicate a constant, we precede that number, that constant, with the hashtag, or also known as the pound sign, which I have there on the slide, in front of the number. Okay, so we're going to put that hashtag in front of our constant. And now I just want to point out that was for the source. The destination cannot be immediate, because it does not make sense to move data into a constant. No, you move data into an address, right? So we're going to keep that in mind. If we're using immediate mode, we're only going to use immediate mode for the source. And again, in the MSP430 documentation, the nice family users guide, the immediate mode is denoted as hashtag N, and I've got this little screenshot here for you just as an example. And here's an example code. Now again, I'm looking at the operands, which are listed in the third column of the assembly program, and you'll notice that the source is beginning with a hashtag in all of those cases. So that indicates to us that the instructions are employing immediate mode addressing. Now we just got done saying that the destinations cannot be immediate mode addressing. The destinations, in this case, we see the unique register identifiers, R4, R5, R6, R7, and so forth. So these instructions are also employing register mode addressing. So right away now here we see that two modes of addressing may be employed by each or by one instruction, right? There's nothing wrong with that. All right, so again, let's suppose that the registers are cleared, all right? And I'm eyeing up that first move instruction, and it's got a constant 1, 2, 3, 4 in hex, and then it says that the destination is R4, and sure enough, yes. So after that line is executed, I will have 1, 2, 3, 4 in hex in R4. And I'm eyeing up now the next move instruction, and I see face, F-A-C-E, in hex, and the destination R5. And so after that instruction, yes, FACE in hex gets moved to R5. Now I do want to point out though, in this line, the 0 is necessary before the F in face, because if you recall, the data cannot start with a letter. So we have to put a 0 there, or else we get an error. Okay, so I'm eyeing up that third move instruction. It's a .b, which is just going to move 99 in hex into the lower byte of register R6, right? And same with the next move instruction, R7. It's going to move EE into the least significant byte of R7. And again, notice that I needed to precede the EE with a 0 there, or else I would have an error. Okay, now I'm looking at the next move instruction, the fifth one down, that is, and I see hashtag 371. 371, there's no H after it, right? And so 371 by default is decimal. So this is going to move 371 into R8, and it's a word appended, .w appended to the move, and that's because I believe, let's see, 371 is not able to be, 371 is out of the range of 8 bits. I think it takes 9 bits. 8 bits. 256. Yeah. So 8 bits would be 256. 255, that is. Yes. So we want a .w there to move 371 into R8, and it's in decimal. Now in CCS, you can actually, when you're looking at the register contents, you can right-click on the register, and you can change the format from hexadecimal to decimal. In hexadecimal, I think this is actually 137, which is interesting. 173, I think, maybe 173. I don't know. I think it's close to 371. I think it's 173. So that's just a little factoid, interesting there. But yeah, you'll want to change that then in CCS so you can see the decimal equivalent if you are running this code. Now the next move instruction, it moves 10101010 into register 9. Okay, and that's in binary, so I've appended B there at the end of that binary string. And again, you can right-click on R9 in CCS, and you can have it display the binary instead of the hex. All right, so that was it for those two addressing modes. Next time, we're going to look at some different addressing modes. Thank you.